Hey everyone, welcome back to my YouTube channel Act 1. The anomaly. Look up into the night sky. There it is, our constant companion, the moon. For billions of years, it has graced our heavens, pulling at our tides, illuminating our nights, and inspiring countless myths and legends. But beyond its familiar glow lies one of the most profound and persistent mysteries in all of astronomy. Where did our moon truly come from? How did this colossal sphere, a quarter the size of Earth itself, come to orbit our planet? This is not just a question of cosmic curiosity. It is a fundamental inquiry into the very birth of our world and the unique conditions that allowed life to flourish here. The Earth and Moon are an extraordinary pair in our solar system. Most planets, if they have moons at all, possess much smaller, irregularly shaped bodies that are often captured asteroids. Mars has Phobos and Deimos, tiny potato-shaped rocks. Jupiter and Saturn boast dozens of moons, many of them small, others truly massive like Ganymede and Titan, but even these giants are dwarfed by their parent planets. Our moon, however, is an anomaly. Its sheer size relative to Earth is unparalleled. Consider Pluto and its moon Charon, often called a binary dwarf planet system due to their comparable sizes. But Earth is a full-fledged planet, and our moon is far larger than any other planet's satellite relative to its host. This immense scale immediately tells us that something extraordinary must have happened in its formation. The moon's orbit is also peculiar. It does not orbit precisely around Earth's equator, as one might expect if it had simply condensed from the same material as Earth. Instead, its orbit is slightly tilted, a subtle clue that hints at a more dynamic and violent past. Then there is the moon's composition. While sharing many similarities with Earth, particularly in its outer layers, it also exhibits crucial differences. Lunar rocks are remarkably depleted in volatile elements, substances like water, sodium, and potassium, which evaporate easily. This suggests the moon underwent intense heating at some point in its history, a process that would have boiled off these lighter elements. Furthermore, the moon has a much smaller metallic core relative to its overall size compared to Earth. Our planet boasts a massive iron-nickel core, generating a protective magnetic field. The moon's core is tiny, almost insignificant, a difference that needs explaining. For centuries, these discrepancies were simply observed, pondered, and often attributed to divine creation or unknowable forces. But as humanity's understanding of physics and planetary formation grew, these anomalies transformed from curiosities into profound scientific puzzles. They became the fingerprints of a cosmic event so cataclysmic, so transformative, that it literally shaped our world and gave birth to its celestial companion. This event, now widely accepted as the leading theory, involved a collision of epic proportions, a cosmic dance of destruction and creation. But the details, the precise choreography of this ancient ballet, remain hotly debated. The ghost of a missing planet, a theoretical body we call Theia, looms large in this narrative, a silent witness to Earth's violent birth. What was Theia? Where did it come from? And how did its demise lead to the formation of our beautiful, mysterious moon? The quest to answer these questions is a journey back in time, to the very crucible of our solar system's formation, to an era of unimaginable chaos and breathtaking creation. Act 2, the first clues asterisk. For much of history, the moon's origin was a subject of speculation rather than scientific inquiry. Early astronomers could only observe its movements and surface features. It wasn't until the dawn of modern astrophysics that scientists began to propose concrete mechanisms for its formation, driven by the desire to explain the anomalies we just discussed. The earliest scientific theories were relatively straightforward, attempting to fit the moon into known astronomical processes. One of the first widely discussed ideas was the *** fission theory ***, proposed by George Darwin, son of Charles Darwin, in the late 19th century. This hypothesis suggested that the early Earth, spinning incredibly rapidly, essentially spun off a chunk of itself. Imagine a blob of molten rock, rotating faster and faster until a piece tears away, eventually solidifying into the moon. Proponents of this theory even pointed to the Pacific Ocean basin as the potential scar left behind by this dramatic event. However, the fission theory faced insurmountable problems. For Earth to spin fast enough to eject such a large mass, it would require an enormous amount of angular momentum, far more than the Earth-Moon system possesses today. There was simply no plausible mechanism to explain how Earth could have acquired and then lost such a tremendous rotational energy. Another popular idea was the *** capture theory. This proposed that the moon formed somewhere else in the solar system, perhaps as an independent planetesimal, and then, by chance, wandered too close to the young Earth and was gravitationally snared into orbit. This theory could explain some of the compositional differences between Earth and Moon, as they would have formed in different regions with different materials. However, capturing such a large body into a stable orbit like the Moon's is an incredibly difficult and improbable event from a physics perspective. It would require a very precise trajectory and a mechanism to dissipate the excess energy of the incoming body, often requiring a third body or a very dense atmosphere. neither of which seemed likely for the early Earth-Moon system. Direct capture would more likely result in a collision or a slingshot effect, sending the moon hurtling away. The *** co-formation theory **, also known as the condensation theory, suggested that the Earth and Moon simply formed together, side by side, from the same swirling disk of gas and dust that gave birth to the rest of the solar system. In this scenario, the Moon would be like a smaller sibling, condensing from the same parental cloud. While this could explain some similarities, it struggled to account for the Moon's